Okay, so integration by parts. We started with uv. If you take the derivative of uv, it gives us v du dx plus u dv dx. And we were asking the question, what would happen if you just integrated this thing? So we're going to use the integral as an operator. Just kind of throw it in here. Don't forget the differential. And then let's do the same thing with the two terms on the right. So let's go with red on that. So I'm trying to show you that the integral symbol is something we can use whenever we wish. So we can integrate equations. We actually did that with derivatives. We differentiated like the Pythagorean theorem, if you remember at one time. That was when we were doing related rates. We took a squared plus b squared equals c squared, and we took the derivative of that. Right? It's like derivative is like something you do. Right? So we're just integrating it. And what cancels out here? The dx's all cancel out, like that, which gives you this statement here. The integral of d of uv equals integral of v du plus integral of u dv. So you might say, well, big deal. Well, let me ask you a quick question here. What is the integral of dx? If you just see an integral symbol and a bald differential like dx standing there, what is the answer to that question? What is integral of dx? No, not f of x. Think of the fact that there is a 1 here that no one would ever write. What function has derivative 1? X, right? So x plus c is the answer. What if you saw integral of dr? What would that give you? R, right, of course, plus c. What if you had integral of d, I don't know, happy face? Happy face plus c, because the derivative of happy face is 1. If you're differentiating with respect to happy face. So it turns out that this left side, what is the left side of this equation we've written here in black? What does this come out to be? uv, right? And we're going to actually not need the plus c because this is an equation and there'll be a plus c on both sides anyway. So that comes out to uv for the same reason these all worked, right? And then this part, well, I don't know what v is. I don't know what u is, so I'm just going to have to leave it like this. But this is a new rule. This is called, well, this is the rule for integration by parts. I'm not sure it even really has a name. But it's kind of customary to solve this for this term. So we're going to isolate this real quick. And we end up with this. The integral of u dv is uv minus the integral of v du. And I had a student last year who insisted on calling this formula suduv equals uv minus svdu, which is ridiculous, but this is how he memorized it. That was Tristan Hatchell. And it's suduv equals uv minus svdu. I think we should say it together. So we're pronouncing the integral symbols as s's. Okay, let's say it together. Ready, go. Suduv equals uv minus svdu. You're probably never going to forget it, and that's the goal, right? Okay, this thing is incredibly powerful. Okay? As you'll see in a minute. So before you start your homework, write this at the top of your page. Before you start your test, write at the top of your test. You know, every time we go to the next example, write it down again. Let's get started on some examples. Okay, this thing's going to give you wings to fly when it comes to integration. So let's say you're given a problem like this one. Example 1, I chose integral of x times cosine of 2x plus 1 dx. See, this problem cannot be solved with a trig substitution. You might be able to use change of variables on it, but it's awkward. I haven't tried it. but it just is not a friendly problem at all. Okay? So the first thing I notice is it's made up of two parts. There's an x, and then there's a cosine of 2x plus 1. So what I'm going to do is I'm going to choose part of this integrand to be my u, and the rest of it to be my dv. Okay, so it's a little bit different from u substitution. You're not just going to pick a u, that's not where it ends. You pick a u, and the rest to be dv. So I'll get you started on this one. I'm going to let u equal x, and dv will be everything else you see here. Cos 2x plus 1 dx, all of it. So this is my u, and the rest is my dv. All of it, including the differential. Okay, now, I'm going to find the derivative of u. So in other words, the differential of u, just like you did for your substitution. So what would du be? 1 dx, right? So just dx, right? If dv is cosine 2x plus 1 dx, then what is v? Now you have to sort of integrate this dv to figure out what v was. What has a derivative, or what has a differential cos 2x plus 1 dx? 1/2 sine 2x plus 1. You're right. 1/2 sine 2x plus 1 is the anti-differential, I guess you could say, of 2 cos x, or cos 2x plus 1 dx. Okay, so watch what happens. We have a brand new formula. Let's write it. It's sudov equals uv minus sfdu. We got this from integrating the product rule. Let's plug in everything. So what is sudov? Well, it's x dx, dv, so that would be cos 2x plus 1 dx. Okay, so that's just the original problem. Sudov is the original problem. Equals, now uv. What's uv? Sounds like a Swedish word, uv. Look at your work, you've got a u and a v. What is uv? Yeah, it's the product of these two. See? So it's going to be x over 2 sine of 2x plus 1 minus sfdu. When I say sfdu, I mean the integral of v du. So the integral of v du fortunately is just dx, that's nice. And there's a halfer there. I'm just going to put that in front of my integral. I don't like having the half inside the integral like that. Okay, now it turns out that what you're looking at on the right side is your answer, okay? Right here. This is all your answer, right? But this integral needs to be evaluated still. No big deal. This is easy. This just has antiderivative negative cosine of 2x plus 1. There's a half. So this becomes, for a final answer, x over 2 sine of 2x plus 1 plus 1/4 cosine of 2x plus 1 plus c. Never forget the plus c. That is very powerful. Okay, let's just for fun take the derivative of it and see if it returns us all the way back to home base. Okay, so let's just check our work real quick. Check. If I take the derivative of this first term, I'm going to need the product rule. So it's going to be 1/2 sine of 2x plus 1 plus x over 2 times cosine of 2x plus 1 times a half. Okay, now I'm on to this term. Oh, I see it got kind of cut off there, guys. Let me move my projector up a little bit, sorry. I'm just taking the derivative. All of this stuff was just the derivative of the first term in Okay, and the derivative of that second double underlined term is 1/4 times negative sine 2x plus 1 times 2 from the chain rule, so I'll make this 2/4. And you'll notice that this completely cancels out with this. Something's not quite right. Oh, Mr. Shore made a mistake right here. This is why we check our work, right? There was a 1/2 here in front of my second integral, and the antiderivative of sine 2x plus 1 is 1/2. Actually, it was right. I must be wrong during my work checking here. Let me check it again. Oh, I see. I crossed out the wrong things. Actually, yeah, the two things I crossed out actually add together, don't they? No, hold on. Oh. No. It actually checked out just fine. I just can't figure out why there's a... Why did I put a 1/2 here? Okay, I'm crossing out my mistake right here in black. This was a 2. There we go. Yeah. Okay, so this 2 cancels out with this 2. There it is. X cos 2x plus 1. My original integrand. I'll circle it in the original problem. Okay, so that's pretty rewarding when you get it right. A little hard to check your work, but if you take the derivative, you should get the original integrand, right? Okay, so that's a brand new technique. Let's try another one. How about this one? The integral, example 2. The integral of x e to the x dx. It's a brand new problem. We've never done this before. Let's pick our u to be x. And then the rest of this garbage, we'll label that dv. dv. Okay, so what is du? Just 1, right? 1 dx. Okay. What is v? Ask yourself, what function would have differential e to the x dx? What would that be? Just e to the x, right? Okay. And so we believe that the integral of u dv is uv minus the integral of v du. You know, pseudo v equals uv minus vdu. And we plug everything in. So the integral of x e to the x dx is equal to, okay, now what's uv? X times e to the x, good. Minus the integral of vdu, so that's just e to the x dx. So my answer is x e to the x minus e to the x plus c. So this is u times v, and this is minus the integral of v du, which is dx. And the integral of e dx is e dx.
Will uv always be the integrand of the original problem?
No, that did not happen in example 1. Good question. He's noticing that uv is the original integrand, but that's not true in this example, right? Uv was that garbage. That's not the same thing as our original integrand. Good question. That's a coincidence on this one. Okay, let's go on to the next problem. Example 2. Let's say you wanted to integrate I just want to make sure I pick a good example here. Thank you. We're on example 3. I wanted to do x squared sine x dx. Okay? This is my next example. Okay, so how do you pick your u? This is a really important question. As you remember from u substitution, that's not a trivial question. That's important. Because basically, if you pick the wrong u, you end up kind of dead ending, right? I that once or twice. Me too. Okay, so that happens. Listen, when you pick your u, remember you're planning to differentiate it, right? So you could actually pick x squared, because you know the derivative of that. Or you could pick sine x, because you know the derivative of that. But listen, when you pick your dv, it's got to be something you can integrate. Okay, because you're supposed to pick a u and a dv, you differentiate the u and you integrate the dv. So you better make sure that you're comfortable doing that. So I plan on using the x squared for my u, and I'll use the sine x dx for my dv. Because I don't have any trouble integrating sine x dx. That's not a problem. Or on this problem, I could actually reverse it. I could actually make this my u, because I'm not scared of integrating x squared. Okay, so there's kind of two philosophies on this. I could go let u equal x squared, in which case du would be 2x dx, right? And then how do we pick our dv once we've picked our u? It's just everything else, right? So that means dv is going to be sine x dx. Okay? Whose antiderivative would just be cos x, technically negative cos x. So I did it that way. Or, like I said, you could have used the sine x as your u, and the dv would be x squared dx. That would work too. So sometimes it's kind of a 50-50. But whatever you pick for dv, make sure you know how to integrate it. Okay, so this integral, which we would never be able to solve before today, is going to be uv minus sfdu, right? So uv is what, class? Yeah, it's x squared times negative cos x. So I'll just write that as negative x squared cos x minus sfdu. So that's the integral of v du. Oh, yuck. Du is 2x dx. Okay, I don't like having the negative inside the integral like that. So I'm going to rewrite this real quick. I'm going to put that plus 2 in front. There we go. So the inside, the second integral now is x cos x dx. Like that. There we go. Okay, still kind of stuck. Let's do it again. Let's do integration by parts a second time. Let's pick u again. Let's pick a dv. And let's break down this integral. So now we're focusing on this integral. What might you pick for your u? What do you guys suggest? X, okay, so let u equal x. In other words, du is dx. Okay, what do you pick for dv? You don't have much choice, you've already picked x. So what's your dv? It's this cos x dx. We have to. No, we ran into another integral we can't solve. So we're using parts again. So what's v? Sine x. That's right. Just simply sine x. Alrighty. So this part we already solved from the first IBP. And now we're doing uv minus fdu again with new u and v, new du and dv. Okay, so let's do another uv minus fdu. So what's uv now? I'll draw it in red. What is it? X sine x minus sfdu. So that's going to be integral of sine x, and then it's du, which is just dx. Okay, so what we did is we got this down to a very simple integral. And this is the answer. With the two distributed. So the antiderivative of sine is negative cosine. That's why it turned out positive here. And this too is just distributed in now. So it's here. Don't forget the plus c. So that problem had 2 iterations of IBP in it, integration by parts. Tomorrow I'll show you how to do that problem in under 30 seconds using tabular. Okay? So we'll save it for that. But unfortunately, tabular doesn't work on every problem. So we see that integration by parts is not something you do just at the beginning of a problem, but sometimes even in the middle of a problem to solve it. Okay, the cool thing about integration by parts is not that it can solve a bunch of exotic integrals. The cool thing about integration by parts, in my book, is this next example. Watch. Let's say you're just given something like integral of ln. Right? That is so simple. Right? But do we know the function whose derivative is ln x? I don't think we know it. So let's use parts. The interesting thing about this integrand is it's so simple. I guess the only thing we could pick for u is ln x. We don't have much choice. So I guess for u, we're picking ln x. There's not much here to pick from. I guess u is ln x. Alrighty. So once we've picked our u, I guess everything else is the dv. This is a very interesting problem. What's dv? I guess if this is my u, then this is my dv. I don't have a choice. Okay, so I had to pick a u, so I chose ln x as the only thing around. And then I had to pick a dv, that's just everything else that's left over, and that was just the dx. Okay, let's go and find du now. How do you find du? Basically take the derivative, right? So it's 1 over x dx. Let's find v. V is x. And we don't need any of that plus c stuff in our little intermediate work. We'll just slap a big plus c at the end of this problem. Okay? All right. So what is today's rule? IBP rule, say it. Suduv equals uv minus svudu. You got it. Okay? So suduv is just the original problem. Right? What's uv for this problem? X ln x minus integral of x. This is so cool. There's your v. What's du? 1 over x dx. Oh, so this is just 1 right here. Okay, so it's x ln x minus the integral of 1 dx, which is just x. So last year in AB, I told my students that they should know things like the derivative of ln x is 1 over x, and I also told them that they should know the integrals of certain things, like, you know, the integral of 1 over 1 plus x squared is arctan, stuff like that. But I actually had them memorize this one. I don't know if you remember this one or not, Hugh. The integral of ln x is x ln x minus x, but we didn't know why at the time. I mean, I didn't explain it to AB, but it comes from IBP, is where it comes from. Pretty cool. You could actually go back, this is really neat. You could go back to these 3 problems we did as a warm-up, and you could do every one of them in parts. You could write this as cot. And use, be really good, use the cot, and then for the first cot, use that as your u. For the other cot x dx, use that as your dv. You could use uv minus uv. Okay? It would work. The idea is here is a little easier. But this would work. All right. And the last one I have is one for you to try in the last 5 minutes of class. So which example are we on? That sounds right. I had 5 picked for today. I'm going to have you do this one. It's actually not a hard one to get started because you don't have much choice. You have to pick u equaling ln of 1 plus x squared. You don't have a choice. So this will get the ball rolling. Here's your u. I guess your dv is going to have to be dx. Okay, so carry on from there, see if you can get uv minus vdu, and then you'll know what the antiderivative of. Okay, so you start off by writing down your u. You don't have much choice. It's just ln of 1 plus x squared. You write down your dv. That's whatever's left over. So what did you guys end up putting for du? What is the derivative of ln of something?
2x over 1 plus x squared.
Yeah, so you're supposed to use 1 over 1 plus x squared. That's because it's a natural log. And then times the derivative of the inside. So it's times 2x. So how many of you got this for your du? How many of you remember to put the dx there? Good. Okay, as for v, what's v?
X.
Simply x. So uv is going to be this minus svdu, the integral of v du is going to look like this. So this is v and this is du. Okay, so here's what we end up with. X ln 1 plus x squared minus the integral of 2x squared over 1 plus x squared. And we can also put that 2 out front. Let's do that. Okay, so we're into a bit of a problem, though. Give me 1 second. We don't know how to integrate this. We still don't know how to integrate this, and parts might not help. So what you want to do is long division here. How many times does 1 plus x squared go into x squared? This is what we call an improper fraction, where the top and bottom are equal degree, or if the top has a bigger degree, long division will clean that up. So this goes, let's write this as x squared plus 1 goes into x squared how many times? Well, first it goes in once, and then you multiply it to get x squared plus 1. You subtract, so you get minus 1. So you have minus 1 over x squared plus 1. So what this does is this just allows us to write that integrand, that second integrand, a little bit simpler. So now it's something we're very comfortable integrating. You can do this one in your head now. Okay, so what's the antiderivative of 1? X. What's the antiderivative of 1 over 1 plus x squared? Arctan. Right. So the answer is x ln 1 plus x squared minus 2x plus 2 arctan x plus c.
How did you get the long division? I don't understand.
Long division will take a improper fraction where the tops and bottoms are equal degree, and we make it so it's not like that, and everything is truly fractional, like the tops are smaller than the bottoms, and then it's easy to integrate.
I get the. Is that
It's like we do 3 into 65, right?
The fraction of
the fraction at the end is what I don't get.
This? Okay, let's say you're doing 3 into 72. You would say 3 goes into 7 twice, you don't try. Don't just count. Well, that didn't work. Let's do
I was like, that's
Okay, you get to here.
Is it plus 1/3? Is that why? Is it the remainder?
Yes.
I think I was wondering.
Yeah, this goes into 20. So 6 times 12. So you would say 1/3, right? Plus a third.
Okay.
So the remainder gets put over the divisor from your second term. And then it's really easy to integrate. Okay, have a nice day. Bye.